In this lesson, we're going to look at something called prime factors. Now, prime numbers are numbers that only divide by themselves some two separate factors and only two factors, but they're a bit more interesting than that. In fact, prime factors are like the building blocks of the whole number system. I'm going to show you why. Basically, any number can be written as factors involving prime numbers. So you can take any number and break it down into prime numbers that multiply to make that number. And this is called a process called prime factor trees, and I'll show you what I mean by that. So here's a wee definition. Prime factors of a number are the prime numbers that multiply to give that number, and every single number can be broken down into this idea. So let's look at this first example. We'll take 48 and we'll break it up into two factors. So things that multiply to make 48. Now you can pick any one, so I'm going to pick 6 and 8. Okay, I'm now going to look at 6, and I'm going to break that into factors that make it into 6. So factors that make up 6 are 2 and 3. Now you stop this kind of process of going any further when you hit prime numbers. So I've got a prime number there, I've got a prime number there, so I don't need to go any further. I'm now going to turn my attention to the 8. So 8 can be split up into 2 and 4. Now the 2 I can't split up any further, so I'm going to leave that. But 4 is not a prime number, so I'm going to break up the 4 into two factors that multiply to make 4, 2 and 2. Now what you'll notice is at the end of my wee tree parts, all these wee green bits, these are all prime numbers. What we're saying is that basically if you multiply all these prime numbers together, you will get 48. So 48 can be written as prime numbers multiplied together, or prime factors. So 48 is the same as 2 times 3 times 2 times 2 times 2. And we'll test it out. What's 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24, and 24 times 2 is 48. As I say, they're kind of the building blocks because everything can be made from prime numbers. Every single number can be made from that. There's a nice wee shortened version of this that we can do. Instead of having 2 times 2 times 2 times 2, if you've watched the powers and roots video, we can actually do 2 to the power of 4 there times 3. So I'm going to write that as 3 times 2 to the power of 4. Now you can start with any factor pair, but you must end up with prime numbers at the end of each wee branch. This is these wee green bits here. So we didn't need to start with 6 and 8. You could have started with 4 and 12 and it would have still worked out. Okay, I'm going to show you what I mean by just picking a number. Let's pick 36 and let's try this again. So I'm going to take my 36 and I'm going to break it into factors, two numbers that multiply to make 36. So I'm thinking 6 and 6. So that's the automatic reaction, isn't it? 6, and we'll go for 6 again. Right, are they prime numbers? No, so they will break up again. That one will go into factors. So 6, you could go 2 times 3. Now they're prime numbers, so I'm going to put them in as green. So we'll go for 2. And we'll also go for 3. Now this 6 here is also going to be split like that. Now it's a good idea to kind of try and space these out a wee bit, I suppose, because otherwise they're going to kind of bump into each other, aren't they? So we'll do the same kind of thing over here. We'll go for 6 and break 6 up into 2 and 3. So in fact I'll clone them over and I'll make it quicker. So there's 2 and 3. Now I've got prime numbers at the end of my branches, so we should be able to say that 36 is equal to 2 times 3 times 2 times 3. So I'm going to write that here. So we could write 2 times 3 times 2 times 3. Now that's fine, but I can also notice that could be 2 squared times 3 squared. So let's write it like that. We'll go 2 squared. No, I'll change that in a second. So 2 squared times 3 squared. Now 2 squared is equal to 4 and 3 squared is equal to 9. Yeah, so that works. Okay, let's try it again. One more time. We'll just pick a number at the top there. I'll get rid of this. Let's pick, I don't know, 45. Okay, so I'll change this to 45, and I'll try and break it up into prime numbers or prime factors. Right, so 45, let's start, and the first thing I'm thinking is we could go for 5 and 9. So 5 and 9. Now 5 is a prime number, so we'll have that in the green there. So we'll go for 5. Now 9 is not a prime number. Now what that means is I can't go any further with the 5. 5 is a prime number, that's where you stop. But 9 is not a prime number, I can continue with the 9. So I'll go down with the 9, and I'm thinking 3 times 3. Now they're prime numbers. So I'll put 3 in. And then I'll put 3 in here. Okay, so we're suggesting there that 45 is equal to 5 times 3 times 3. These prime numbers multiplied together make 45. Test it out. 5 times 3 is 15. 15 times 3 is 45. Or you could write it as 5 in a shortened way, 5 times 3 squared. Okay, so that's how to get any number into prime factors as a multiple of prime factors.